So, this is my room, and as you can see, it has a window which faces straight out onto the street. And yeah, these basement flats often have the problem that break-ins are quite frequent. So someone's breaking in, and of course I've got my nice computer here. So what I'm doing is I'm building a sensing and IoT system which can detect threats coming by my window. So here I've got my Raspberry Pi, which is mounted on the inside of the house, and it's connected to a thermal camera which faces onto the street, maybe like this, and it can sense heat information. So for instance, when someone's passing by. So now of course the question is, how does the system work? So basically I have two GitHub repositories, one for the Raspberry Pi and one for the Mac, where I do data analysis and visualization. So if we look at the Raspberry Pi first, it does two things. It uploads data from the AMG8833, the thermal camera, and it uploads data from a weather API to display weather-related info for when no one's trying to break in. So weather data is uploaded at 1 Hertz. This is the script for that, and it looks a bit like this in practice. So every second it gets the date time and the sensor raw data, and it then saves it hourly in a text file on my Dropbox. So it's uploaded there to avoid data loss and to have hourly updates. And the weather data looks like this, slightly less entries here because we only have 2 samples per hour. Then the data is concatenated because we need one big file again for this analysis. I'm doing it from end of November to end of December, so 1 month of data. And the way I'm analyzing it is through a Jupyter notebook. So I load the data from the JSON files. I compute when someone has passed my window, so I'm using a custom peak finder algorithm in the sensor data to determine that. I create pandas data frames, and then it's the usual stuff, analyzing the data, validating, doing some cross-validation between sensor and API signals, so that's also interesting, and then just loads of plots here with weather, histograms, autocorrelation, or thermal images, which is also quite interesting. And all of this is displayed on my data dashboard, which is web-based. And here you can see, for instance, the biggest threats which pass by the window. Who else was passing by? How has the weather been? And so on. And exactly, there's one more feature which I will discuss shortly. So the final feature is slightly more use case based. So here we have a classic situation where someone's trying to break into my room. In this case it turns out to be myself. So here I come, and then I try to smash the window, but of course the system has detected me. And now what's happening is that the system autonomously sends an alert through an instant messaging service, Telegram, which is exactly like WhatsApp, to the person living in that room, telling him, hey, someone's trying to break into the house, with a thermal image. And afterwards the user can also request manual updates. So here we see it. I am chatting with my chatbot basically. I say /start, which starts the auto tracking. And now exactly, a threat has been detected. That was when I was in front of the window. Somebody's at your window. We see the thermal image. So this is me probably just going down again. And then I can also write commands like /update to get the most recent threat which has been detected. Yeah, and that was my project. Thank you very much for listening.